Yeah, so I'm Matteo Manello. I can start with the introductions from Odoma, R&D project manager there. Odoma is an SME, so definitely not the scale of Infobip, specialized in AI-driven solutions and personalized user experiences for the cultural heritage, and both the public cultural heritage and also the private cultural heritage. And you already met if you were here the last days, but if you were not, you'll meet today also members of the team. We have Valeria, Hashtip, and Yuri. And there will be also other members of the work package. So I feel a bit bad about only my name showing there. It's really like the whole work package 4, more or less, that contributed to this. So yeah, let's start. So we have seen graphical interfaces for knowledge graphs over the last days. We kind of brainstormed about functionalities. And we moved today a bit to exploring a bit the language as a possible interface. We're just seeing the voice from Infobip, but today will be more kind of language and written language. So for the slides, if you prefer to have them on your device, you have a bit.ly there. So IPL1-WS7, workshop 7. Yeah, and we can go. So the main objectives for the workshop would be to explore the potential of using LLMs for exploration of knowledge graphs. So when we cannot have like a full in-depth discussion on exploration of this, will be more like to get an intuition and a sense of what they can do with respect to knowledge graphs. I hope you will get a good understanding of the challenges that are related to knowledge graph understanding, especially knowledge graph understanding by LLMs, and especially the challenge of translating text to SPARQL. And SPARQL, if you're not familiar, is the structured language for writing queries against RDF knowledge graphs. And then we also want you to discover a bit the work we are doing in Graphia, Odoma and all the other partners, Net7, the European Data Science Factory, and other partners in Odoma about this problem. So the knowledge graph is not there yet, the Graphia knowledge graph, where we are preparing kind of the solution. Once the graph will be there, how can we actually explore it using agents and LLMs? The program is already, it was meant to be flexible, so it will stay flexible. There will be an initial introduction by me with some Q&A. The break, depending on how we are doing, we skip it or not, also depending on how much energy you have, we'll see. We planned for it, but we can be flexible. And then the second part would be much more hands-on, with a hands-on activity that continues the work on the competency questions that we started yesterday, and also some demos by 3 different partners in the work package. So the context for the workshop is the work we're doing in work package 4, where we're really exploring the synergy between knowledge graphs and LLMs. And I think this has come up already in the past days, that knowledge graphs for LLMs are really important as a grounding factor, a source of factual knowledge that can ground LLMs and avoid them to hallucinate. So we are really exploring the synergy between the two in terms of using LLMs for constructing the knowledge graph or enriching the knowledge graph, and also in terms of then using, once the knowledge graph is there or other knowledge graphs are there, using LLMs to explore them. And here you have, and I forgot to mention, you see already, the PCSS, so our supercomputing, Polish supercomputing center, which is partner of Graphia and in WP4, who is providing the amazing infrastructure where all the AI-related things that we are developing is running. Probably we don't need, after 3 days of this, we don't need a slide on what is a knowledge graph. But a knowledge graph, it's a structure, if you want, it's a structure representation of knowledge that we find already in the real world. So take, for example, an archival document about an association, like here, the Swiss Engineering Association as an example, that contains different bits of information. This document and other documents constitute knowledge about real-world entities, which is all unstructured. What the knowledge graph does is to bring this into a structure, adding relations, adding types, and giving structure to this already existent knowledge in many documents of the real world. Also, I don't want to go too much in detail about different types of knowledge graphs. What I wanted to say is that we're going to focus for this session on RDF knowledge graphs, so relying on semantic web technologies and SPARQL as a query language, but that's not the only type of knowledge graph. There are the LPGs, so labeled property graphs. So think of graph databases like Neo4j and Cypher as a query language. But for these details and also a kind of more in-depth introduction, I really wanted to point you back to the video of a webinar by Julian that was really great, even for me, like to learn more things about knowledge graphs. So interested in more, just go there and check it out. Yeah, so we're not building this for any very vague users. And here I wanted to give a shout out to the Aberdeen University and the work they're doing in their work package about fleshing out what are the users that we are doing this for, which I think is very important to keep in mind when we develop stuff. And when it comes to exploring a knowledge graph, we have a very wide spectrum of users. I think on the one hand, there will be people like Eleni, lead data engineer, good technical skills, probably able to write her own SPARQL query. And then on the other hand, we have Sofia, a professor in cultural studies, who is complaining because ChatGPT oversimplifies things a bit too much and is nuancing, is missing this nuancing in the results it provides. So this you can also kind of project it on the LLMs for exploring the knowledge graph. Sofia is very likely to want kind of a grounded, factual, grounded reply to our questions to the bot. So these are the users we are doing it for. And types of interaction, I had these slides before the workshop. So the current interfaces for knowledge graphs provide kind of a wide variety of, but not super wide, but a variety of types of interaction in their interfaces, going from the classical search by text and by image. So now there is a lot of multimodal models out there that allow you to go to switch kind of between the two modalities of text and image very kind of in a fluid way. So you can search text by using images. You can search images by using text. That's quite kind of classic type of interaction. There is the graph-based navigation. So this we had it also in kind of the brainstorming. But not all users are super familiar with this. Also depends what you're looking for in the knowledge graph. Can be distracting, can be not super intuitive, especially when it comes, in my own experience, to humanities scholars. And I'm one of them. Property filter, so drilling down the stuff you're looking for, kind of digging into the what's in the knowledge graph, and the properties from the knowledge graph are kind of mapped into filters of the interface, and then you can filter out, and then arriving to be able to query the knowledge graph by SPARQL. So this is kind of a more or less an increasing level of specificity, going from something generic and also easy to use to something that gets you like the very specific results you're looking for, but it's also very hard. It's quite hard and challenging to write it yourself. And then there were lots of ideas in the post-its about other possible types of interaction in their interfaces, and I hope we'll have time in Graphia to develop some of them. I changed the slide this morning because the slide was saying beyond SPARQL, and then I realized that what I meant was not really to go beyond SPARQL, because even what we are doing with the agent, it still relies on SPARQL. So it's more like what I meant was beyond writing SPARQL by hand, because SPARQL will still be the way that the agent interacts with a knowledge graph in order to get data out and in potentially. So yeah, as I said, varying technical skills of Graphia's target users. So not all of them would be familiar with SPARQL. I think the downsides have been already mentioned, the steep learning curve, the high technical barrier that this poses to knowledge graph. And I think in the cultural heritage, there is, and we are discovering a lot of knowledge graphs, SPARQL knowledge graphs out there, but they could be used much more widely and much more if they provided other types of interface to their data. So by having SPARQL as the only way of accessing them, you are kind of narrowing down your reach to other potential users. People have long been exploring kind of possible solutions to this. There are also in research people who have tried to do everything with SPARQL. There is a quite successful project and tool, SPARQL Anything, that allows you to use SPARQL for querying any type of data, CSV, JSON, and then kind of translating them all into SPARQL queries. So it's not that everyone wants to go beyond SPARQL. Some people really like it. But yeah, I think for our type of target user, it would be important to go beyond. So one possible solution, and I'm glad Julia mentioned it, is the kind of a visual SPARQL query builder. So ways of creating, crafting your own requests in a visual way. So having icons representing different entity types and bringing them together into a form of query, which is better than writing SPARQL by hand. But it still takes understanding of the entities that are there. How do we need to relate things in terms of filters and successions of steps? So there is still, the technical barrier is lower, but it's still there. And then one of the possible solutions we are exploring is the leveraging the capabilities of LLMs to do this translation between natural text and structured languages for knowledge graphs. So there are other examples out there that people have been doing and providing text to SQL, which is the language for databases, text to Cypher, which is for Neo4j and other graph databases, and then our text to SPARQL. So the idea is to have a type of agentic LLM that enables you to talk to your graph. Let's dig a bit into the problem of having large language models to understand what is in a knowledge graph, and also the challenge of developing a generic solution for knowledge graph understanding. So there are vendors like GraphDB, and you will see a demo later, that already provide this type of functionality, but we really were striving in our work in trying to be agnostic and generic. So instead of like going for one vendor that provides a solution, try to crack the problem of providing something that works for any knowledge graph potentially out there. So there are some challenges related to the translation and some challenges related to also the knowledge graphs in the wild. So for the translation part, the real challenge is to provide the LLM with sufficient contextual information about the content of the knowledge graph. So if it's not a very famous knowledge graph, the LLM is not going to know what's inside. And therefore, it doesn't know necessarily how to craft the correct SPARQL queries to give you an answer. And then that's the problem we already started evoking yesterday. There can be, and there is, kind of a misalignment, which is natural, between the vocabulary of the question, of the natural language question by the user, and the vocabulary of the ontology. And the misalignment will be bigger if the user is not very technical, so it will not know the terms from the ontology, it will just use their own terms. So maybe not mention, not say tennis player, but say athlete. We had the example yesterday. So there is this problem of misalignment of vocabulary. When it comes to the challenges of knowledge graphs, we have been discovering with Harshdeep the differences between backends. So wide variety of backends. You have Virtuoso, Allegro Graph, Blaze Graph, Clever, and I forgot some of them. They have sometimes different levels of providing SPARQL support, like different versions of the specs or the specification, and also they will have different performances. Some of them are really performant, also depending on the scale of the data. In some cases, we found kind of, for example, high usage of name graphs that changes the structure of the knowledge graph. So you cannot assume kind of homogeneous and stable structure of this data that you find. And then there is the challenge of the scale of data. So providing a solution that scales well with knowledge graphs that contain billions of triple is not. It depends also on their backend, but it's also not easy. Going more into this, so what are the kind of the elements of a knowledge graph that we are leveraging in order to provide the model with this understanding? So the first bit relates to the content, like how many things are there and of what type are there in the knowledge graph. So like building automatically a statistical profile of classes and properties in the graph. And this the format in which this is expressed, then for the LLM is void, so this vocabulary of interlinked datasets, and I will show an example in a second. The second element is the vocabulary. So grasp from the knowledge graph, what are the elements of the vocabulary, like classes, name of classes and name of properties that are used to describe the things in the knowledge graph. And for this, we use SHEX, so the shape expressions language. There is also SPARQL. We went for SHEX because our needs are kind of limited. I'm not going to go into that. And then there is a third element that we can leverage for any knowledge graph. And the third element are the examples. So we can take some examples from the knowledge graph, give them in the context to the LLM to say, well, your query needs to be based on some of these examples. And there are several problems with this, and I will go to it in a moment. It is the more necessary when the knowledge graph is huge. So from even generating the void and the SHEX description for a very large knowledge graph, you cannot do it in reasonable times on the entire thing. So we need that in order also to generate the other parts of the content. So void, the first type of description we are extracting. Here you see some snippets from the void description from the GUIs knowledge graph, which is one of the knowledge graphs we have in Graphia. For this, we are just relying on some work done by the Swiss Institute of Bioinformatics, because funnily enough, not liking to write SPARQL is not just a problem of the humanities. In bioinformatics, biologists had the same kind of reluctancy or technical barrier to writing SPARQL. So it's not something just for the humanities. And what this generator does is to take the SPARQL endpoint and then generating, I hope you can see some numbers here, generating a statistical profile of how many triples, how many objects, how many classes, how many literal and blank nodes, so details about the knowledge graph, and then going into detail, taking, for example, the class publication reference, how many entities of that type are there, and what kind of relations is this class, does this class have, and how many triples exist for each relation. So this gives to the model an understanding, an intuition about, okay, these are the most prominent type of entities and classes and of relations in the knowledge graph. The second element is the shape expression, SHEX. So SHEX is used for RDF data in order to, is used a lot for validating RDF data, a bit like JSON schema for validating JSON. And we are using it, we are kind of, I don't know if we are misusing it, but we are using it for a different purpose than what it was built. We are using it to describe the shape of data. So what SHEX gives you is, doesn't give you the statistical profile, it gives you for each class in the knowledge graph, you have the namespace, you have the actual name, so you have some vocabulary already in there. And then you have the relations between the different things in the knowledge graph. So this is really about the shape of data and the relations between things that are in there. So providing the model with an understanding about the relations of stuff in there. If you combine the two, and these are some screenshots of me interacting with Claude, the intuition was that if you provide these two plus some examples to an LLM, that will help the generation of SPARQL, but you also will have the knowledge graph just to say, these are the things you can search for in the knowledge graph, which is something that even the user might come to the agent not knowing their domain, but not knowing necessarily what they can search for in a knowledge graph. And we also want to support that. So I was throwing the SHEX file for a given knowledge graph to the GUIs knowledge graph to Claude, and then saying, based on this, what can I find? What can I search for in the knowledge graph? And the GUIs knowledge graph is about publications in the social sciences. So just by using the SHEX, was already able to provide kind of a easy to understand explanation of the things that are in there that I could search for, and was also at some point suggesting these are the search possibilities, these are the SPARQL queries that you can write, some of them didn't work, so you get into this iterative circle of using the co-creation of your SPARQL queries with the agent. So that was like me poking around, and then this kind of fueled what I'm going to demonstrate later on in the presentation. To go not into too many details, but the problem of the sampling of the graph is not actually trivial. So the goal there is to obtain a sample of the knowledge graph that is as informative as possible, so representative, keeping the structure and keeping and trying to capture as much as possible of the vocabulary, especially the predicates that are in the knowledge graph. This, as I said already, we use it for, we need to use it for very large knowledge graphs where you need to kind of a smaller but very representative sample of the whole thing. So for example, with the Open Citations Meta knowledge graph that contains 4 billion triples, we try to extract this sample in a runtime that is reasonable, and I'll come to this later. So we are getting, for example, between 0.3 minutes and 37 minutes. So these are the kind of the different strategies we are testing in order to find one that strikes a good compromise between a very representative sample and a good runtime. And it produces a sample that contains 200,000 triples in the minimum value and 1.5 million triples in the maximum values we had. But you see already it's a very reasonable size sample of a very big knowledge graph. And then we have different sampling methods that we have tested, some brute force, and some methods that entail walking the graph, so taking a node, a random node, and then moving around the graph. The hops are the number of steps of depth that you go into the graph, and there are several ways of doing this in order to kind of maximize the diversity of the things you are capturing, in order to avoid visiting nodes you already visited, and we could have like a whole presentation with Harsh on this, but that's not the purpose of today. So you take these three things together that we extract automatically from any knowledge graph, and this becomes context for the knowledge graph, the LLM in the interaction you have to write your SPARQL query. And I will demo this later. Before doing that, I wanted to open also to before moving to the other parts of the workshop, open to questions you might have, also from online.
I'm curious what you think about the term context engineering, which kind of has come and gone a lot the last couple months. But what you just described seems like one of the most eloquent explanations of that. Like, is that how you think of those three, the content, vocabulary, and example information? Is that, it seems to me like that's a really good articulation of what context engineering might be. Just wondering if you have an opinion on that.
Context is really whatever you pack into the prompt when you send it to the LLM. So context can be used in a very technical way, but it's also, context is also like the context of interactions, the context of words in a book. So what the LLM, because of the knowledge frozen at a certain point in time, it doesn't have, and also the way they're built, it will not have the context needed to be able to write those queries. So that's our idea of the three things that you can leverage in order to build a useful context for this type of interaction.
Yeah, part of that curiosity is the distinction between like user level prompting, system prompting, and then context engineering. Is that a sensible escalation, I guess?
You want to say something over there?
Yeah, so I think like, as you said, right, like some context will be provided by the user, like what kind of question they want to ask, what kind of operation they want to do. Is it an aggregation operation, or do they just want to ask a simple question? But what we showed there with the void checks and the sample, that's like inherent context engineering by default, which is already there, which the user does not know, right? And so that's, I would say, like some kind of system context engineering, something like that.
Plus, there is also the context of the LLM, like the inner knowledge that it's built in the model about the entities described in the knowledge graph. So I think it's a kind of a dense concept and a rich concept when it comes to this type of applications, like the idea of context. Yeah.
I just want to ask this technical details. When you create this checks file, do you generate it out from the RDF graph?
So this is generated, and correct me if I'm mistaken, from the void. So we first do the void generation,
Yes.
and from the void generation, we derive the checks.
Okay.
And depending on the scale of the knowledge graph, either we do it on the whole thing, or we first extract the sample, and then the sample goes into the void generator.
Okay.
So it really depends. Is that okay? Okay.
Yeah, so I felt like yesterday we did the exploration of the ontologies, and I felt like we can just ask you guys to do that work for us, because we are looking at the exactly what you are saying. What are the classes? What are the properties across different knowledge graphs? But we are basing on how the ontology part. We are not looking at the knowledge graph. So I'd like to see what you have and compare, because we are doing it manually, like just looking at ontology and identify stuff. So it will be very interesting to see what you find and what we find.
Sure.
Thank you. Can I please ask what level of detail is potentially going to be held for each artifact or entity in the knowledge graph? Because when it's, say, a journal article, you know, we're referencing a lot sort of metadata, but will there be any depth to what the knowledge graph can hold? Because this is going to be huge, right, across the social sciences and humanities. Because I find it really interesting when you put that simple example into, and it said, how can I prompt, or what can I ask of this knowledge graph? Because say a researcher is looking for more depth, I don't know, an example, they're looking for papers that uses mixed linear modeling, but that's not held in sort of the metadata of papers and things. I'm just trying to understand the capabilities from a researcher level of what they can prompt and what will be in the knowledge graph, if possible.
Yeah. So this depends on the ontology that will be developed, but it also depends on the information that will be extracted from the full text. And one of the things we are planning is indeed to extract place names and people's names, organization names, possibly dates from the full text. So if this is then added back to the knowledge graph, potentially the user can search for that. So the level of detail of the searches that will be possible depends on the richness of the ontology and the richness of the knowledge graph. But we are indeed planning for, especially if when having Go triple inside the knowledge graph with all the contents in Go triple, very often the user, and even myself, I want to go beyond just what's in the title and go into like what's in the text with technical implications, but potentially going there as well.
Thank you very much.
Yes. No, he has raised the hand.
So sorry in advance, I may have missed a part of your talk. I was just wondering about this approach. Can it handle especially contexting? Can it handle more than just text, but also images or whatever data we can put in, and how it may affect the result? And can it be taken into account in your approach?
For now, we are limiting ourselves to the kind of textual content and whatever it's in the triples that describe the knowledge graph. So for now, we're not taking into account, for example, the content of images that are referenced in the knowledge graph. So that's a bit kind of a far beyond, if I understand the question, but maybe. Okay, can you please repeat the question?
No, that was the idea, to know if you can take more inputs than just text and the answer, so it's beyond your work right now.
For now, yes, but it really depends on what's in the knowledge graph. So we can take whatever that's in the knowledge graph. And if in the knowledge graph there are images referenced, potentially one could take them into account. But for now, this kind of reasoning is done on the triples that constitute the knowledge graph, more than in all the documents and images and text that are referenced by the knowledge graph, if I understand the question.
Mathieu, is it okay for you?
Yes, perfect. Thank you.
Okay.
And thank you for the question. Any other comments or question? No. So we need to do kind of a little temperature check of the room. How do you feel about continuing? Or should we just do kind of a 10 minutes break? We go on? Great, then we continue, no break. Okay, so the second part is gonna be more, as I promised, more interactive. And we're very happy to launch today, this week with the IPL. Some work we've been doing on the actual evaluation, on like building the foundations for the evaluation of all this. Because the real problem for any LLM application and agents and so on is then, especially for scholars, to be able to evaluate it, like to know how well the model does in translating these queries. And the evaluation and the benchmarking are super important also to be able to, how much can we scale down these models? So very big and expensive and powerful models are gonna perform well, but what is the smallest model that we can use, especially to make this more sustainable in the future, that still achieves good results? Well, you cannot answer that question if you don't have benchmark data. And benchmark data for this type of task, that it's called in the literature, knowledge graph question answering. They don't exist for SSH. There is nothing comprehensive out there. Lots of work in quite some work in other disciplines, like for example, biology, that inspired actually what we are doing, but nothing that existed for the SSH. So what we are launching and have developed, it's a platform to crowdsource a benchmark data set of query and question pairs for potentially any knowledge graph in the SSH. And this relates very much to the competency questions that we worked on yesterday. So here is the QR code if you want to access it. Best will be from the laptop or a tablet, but it also works on mobile. There is, if you want to know more, Ursula has published a blog post on Koga, which is the name of this platform, on the blog. And here is the address if you wanna go there. Before showing it, and Koga is gonna be what we ask you to work a bit on for the practical part of this workshop, about 10-15 minutes. Let me just tell you what is the goal. So Koga, which is both a reference to a subspecies of a zebra that it's now extinct, but also to the kind of an acronym of the question answering over graphs task. The idea is to crowdsource and then publish, and then acknowledging all the contributors, publish this benchmark data set in order to allow for this type of evaluation. There is also the hypothesis or idea we have of whether the ontologies that are used in the SSH are intrinsically more complex than those in other domains. So some of them are flatter, some of them are more deep and structured. So there is the question of, does this domain have challenges that other domains don't have? And cannot know it until you have a benchmark data set. So it's really hard to have a target for all this because you need to tap into communities that know knowledge graphs that you might not be aware of, that have domain expertise. We are aiming for a first target 200 pairs of questions and queries, but you can also just submit a question if you don't know how to write a SPARQL query. As kind of a benefit of all this, I think there is also increasing the visibility of knowledge graphs in our domain, and potentially using this as a documentation resource and also as a pedagogical resource. There are many resources out there about learning SPARQL in a DH context and so on. Well, if you can have a place where you have hundreds of queries and a catalog of SSH knowledge graphs with examples, I think that's going to be very useful. And the reality is that we are finding lots of knowledge graphs out there and also with examples, but there is not it's very time consuming to go find them and bring all these things together. So to counter the discussion of the hands-on part, I hope you can, well, no, before doing that, I think I should show the interface. So here, I should have logged in. We provide 3 authentications, so with the Opera's ID, with the ORC ID, more for academic researchers, And with a GitHub, hopefully we captured 99% of the cases, but if you are in the 1%, just let us know, and then we're happy to add more authentication options there. You need to authorize our GitHub in order to be able to access Quokka. The only part that it's actually under login is the part for contributing. Yes. Yes. Yeah. Is there anyone in the room who wants to use Quagga, for example, and doesn't have one of the 3 authentications here? Anyone who doesn't have a GitHub OrchID or Opera's account? Okay. Okay, but anyway, let us know in the chat. Also, there is here at the bottom a contact email. If you want to have another type of authentication, the advantage of not having our own system of usernames and kind of a database to host it is also all the GDPR issues related to that. So we are trying to go for already existing authentication systems. But anyway, the only part of this that it's under password is the part for contributing to the knowledge graph. Before showing that, you can already browse what's already inside. So here we know for knowledge graphs, we are using the Go triple taxonomy for a selection of the Go triple taxonomy for describing the fields of the knowledge graphs that are in there. And also we provide this cross-domain category for things like open citations, for example. Open citation is not very domain specific. So you can filter down your knowledge graphs by the domains you're interested in. So here, for example, I go to the EDI knowledge graph with archival information about the Holocaust. You can view what's already been submitted by other users. You can also filter and only see your submissions to be able to kind of modify them. And the submissions are very simple. Some of them have a query and a question, and some of them have only a question. So I think here they are only, they have both. So you get the question, you get the source in case you copied this query from somewhere else, and then you get the SPARQL query, and you are able to run it. I'm not going to run the EDI because they told me that they changed. It's still a work in progress knowledge graph, so they changed it and they broke the queries. But GUIs is more stable on this respect, so I can query. I can run the query outside. I can modify it and play with it, change some parameters, or copy it and then go, for example, on the SPARQL endpoint of the knowledge graph and then do the query there. So this in terms of browsing what's already there. When it comes to contributing, which is kind of the interesting part for us today, you can either start from a knowledge graph that you already that it's already there, that people have already contributed to, or you create a new one. So here we have EDI, Open Citations, Europeana, and GUIs to start with. But if you don't find the one you have, then you can add it. Choose a name, short and informative, the about page, select the disciplines, you enter the description, try to be as informative as possible, up to 100 words, and then we have 2 options for the data, for the access to the data. So either the SPARQL endpoint, if the knowledge graph has it, or a data dump that we can use later to load the data into a local SPARQL. If you're using the SPARQL endpoint link, it's going to be validated, so tested by the application before accepting your contribution. And then when it comes to the contribution, you must provide a natural language question, and the query is optional, as you can see. If you can, write it there. If not, it's still valuable to know from your side which knowledge graph you would like to ask which question. So you will see some similarities with the competency questions. And then you submit it, and you should find your contributions there. So to go back to describing the activity, what we propose here is to head over there, log in. So, and then several scenarios depending on how you position in the spectrum of the user. So if you're aware of a suitable knowledge graph and you can write some SPARQL, then go ahead. Either you find it in the list or you add it, you provide one or more query pairs. Even if we manage in this activity to do like one question query per person, I think will be already a big step forward for building this data set. If you know a knowledge graph, but you don't know how to write some SPARQL, different possibilities. So we provided some prompts in the slides that you can use in order to interact and co-create with Claude or DeepSeek or OpenAI, whatever LLM you have access to, if you do. And then we recommend to iterate in order to arrive to a query that works. Or we also take just a question. So that's already if you point us to a knowledge graph that you would like to query and that we don't have, we'll be super happy. And if you don't know any suitable knowledge graphs, in the slides you will find a link to an issue in our GitHub that contains some examples. I would recommend especially, but there is some more further down because we are discovering more. But already here, these are examples that contain very rich galleries of examples. So you can even try to either take one of them and reference the example source or modify it before you insert it into Quokka. So if you need help with the platform, there will be Harsh here in the room that can help you. Yuri will take a look online if anyone has problems. And then we say, 10-15 minutes for this. Okay, so we move on to the second part of the workshop, where we're going to have 3 different demos from different people. So the first one up is Luca De Santis from Net7, who's going to demo the Go Triple chatbot. So it's not technically, we are going from something more generic to something more related to SPARQL. I welcome Luca.
So one important thing, first of all, thanks a lot, Matteo and the whole Odoma gang for the presentation, which was brilliant. It was about Graphia. Now I'm thinking about the initiatives that we are doing and we have done for GoTriple in the context of other projects, even if, of course, there is a very, very important synergy with Graphia. So what actually are the initiatives AI related in GoTriple? The first thing is the old GoTriple chatbot. Is it named old for a purpose? Because it was done in 2023 as a first experiment actually to understand how we could use this retrieval augmented generation paradigm with GoTriple content. It's still online. If you are curious about it, here you can find the presentation, a poster that we made for the Opera's conference last year. And it is based on a subset of GoTriple content, and actually we can see it in action. We decided just to grab some content in 5 languages. So we have English, Italian, Polski, French, and Portuguese. On a similar set of subjects, so basically on gender studies. And here it is. So you can actually interact with GoTriple content, not only with the metadata, but also with the content of the documents that have been indexed. So as PCSS knows, I'm trying hard to speak a little bit of Polish. So let's try with a question in Polish. And Arek, it's up to you to tell me actually what I asked, and especially if the answer is correct. So, of course, you can ask the same questions in all these languages that are supported. One thing that we really wanted to do is not simply providing answers, but also evidences of how the answers have been built. So here you have the snippets of documents that have been used to produce the answers. And you can see content in Polish, but also in English. So actually, the idea was, in a sense, to respect the tradition of GoTriple of being multilingual. So also what you can do is if you find something interesting as a document, you can actually start working with this document. So for example, you can come and you can annotate with the Pandit annotation system. So really the idea was just to build a whole ecosystem for researchers to work on content found thanks to GoTriple. And this was the first initiatives, so it's still online, but it's, let's say, just an experiment. Actually, right now we have a new chatbot that is in beta testing. So if you're interested and if you are registered to GoTriple, we can actually grant access to it. It is the, let's say, a sort of response to Google's notebook, notebook LM. I guess that some of you are familiar with this chatbot. Of course, just consider the big difference between Google and Net7. But anyway, this is the metaphor that we used. That is, we allow GoTriple users to create collections of documents and use these collections just to interact in an advanced way thanks to large language models. In this case, actually, we give the possibility not only to work with metadata, but also with the full text of the article. Again, this is a demo, so you must be registered to GoTriple, and I assume that, and I hope that everyone here is already registered. As I said, there is this new functionality that is called the collections. So basically, you can track interesting content in these sort of folders. And if you are enabled, actually, you can use these collections to create your own notebook. So for example, in this case, I create this new notebook. I take the collection about Etruscology because you have to know that my sister and my wife are both archaeologists. So I know one thing or two about archaeology, not much, but you know, a little bit of it. And of course, again, I can collect documents written in multiple languages. In this case, there are documents that have the full text attached. So for example, another document in Italian, and I click confirm, and I wait actually for the system to process all the documents. So here already we have this document that has been processed. It takes a while because what it happens is that it takes the metadata describing the article, but also it downloads the PDF and just indexes it. Now we see actually one warning that is the full text is not available because it's too big. But this was done on purpose because this service is free for users. So we are trying to limit the cost for indexing and processing the content. But actually, and I was discussing about it yesterday with Suzanne, possibly we might think in the future to have a sort of freemium model by which, for example, users paying a fee might have the right actually to index all the documents they want, documents as big as they want, etc. So, okay, now I have a selection, and so let's try to do something interesting about it. So, for example, analyze key concepts. And again, this is multilingual, so I just wrote it for demo purposes directly in English, but I can do the same thing in Italian. And so actually I have automatically a summary of this. So this can be useful if you want to do literary review automatically assisted by AI. Also, this chatbot has been developed in the context of a small project called FASCA, whose objective is to create also tools for digital humanists to actually get data to process. So for example, now I write down something that can be turned into data that I can use for my digital studies, for example. So I write it down in Italian. I just ask to extract locations from these documents in JSON format. So sorry, I have to just put the microphone. Okay, so what I asked is, give me the references to locations in the document in JSON format, and for each reference, the number of times that it disappeared. So in this case, actually, I wasn't very clear because I got a very nice JSON, but I got actually the information about the document. So I must be more specific, but I ask this in English, for example. So I say, I want the locations, and for each location, the number of times it appears in JSON format. Okay, is it correct? More or less. Okay, so basically you can engage in a conversational interaction with the chatbot, while the old GoTriple chatbot, for example, it didn't allow you to engage in a conversation. So every question was the same. And another thing that you can do, okay, this is exactly what I wanted, and I can download this. So I have a JSON file that I can use, for example, in a Python script to do some processing. Okay, so what about this one? I say that this is in beta, meaning that right now we are using a commercial LLM, which is OpenAI. So basically we are paying for this. This is why actually it's for just selected users for testing. But there are plenty of new initiatives in the context of Lumen, in which actually we are adding new things and we want them to bring online. The last point is very important. So actually, we are working together with Odoma and the other partners, PCSS, ESDF, in this work package in Graphia, just to have a set of LLMs, open source LLMs that we can use freely for these experiments. So what's going to happen next in the context of Lumen? The notebook LLM that I've just shown is going to be released publicly, but also we want to experiment on having a full chatbot to search GoTriple content, and also an AI-assisted search for GoTriple content. And let's see how they might look like. So the chatbot on GoTriple content is a chatbot that allows actually users to ask questions and find results directly based on GoTriple content. So it's very similar to what I've shown before. The idea is that in this case, we are going to produce the answers only using textual metadata, not the full text. This is still open for discussion, but possibly processing the whole bunch or the full text will be too expensive to do. So this is possibly the simplest thing to make a step forward in the direction of having a full AI-powered GoTriple. And the other thing is still very much in discussion is, and this is useful also being here to understand if you consider this functionality interesting or not, is to have a prompt-based search. That is, we have the normal search in GoTriple. I search for keyword, but also I can propose a prompt-based search in which actually I can write what I'm looking for in GoTriple. The results in both cases will be the same. That is, will be the result page of GoTriple. The difference is that in the last case, actually, I will have the filters and the query conditions automatically produced by the AI. Is this useful or not? We had some discussion with Stefano, with Aberte. Actually, this can be possibly something that can generate confusion to the users, because possibly what they expect when they are presented to a prompt is something like this. So this is really open to, let's say, still being analyzed as a possibility. Okay, so I guess that this is what's happening in the near future in GoTriple. If you have any question, please don't hesitate. Yeah.
Thank you, Luca. I've played around with the new version of the chatbot with Georgia Aberte. I was just wondering how up-to-date GoTriple is in terms of the resources that are part of the database. Just because, for example, I was looking for two specific papers, and the older one appeared, but the newer one didn't. Because I think the chatbot where you can pin down specific papers and then probe them so deeply and have the full text is amazing. But I just wondered of how recent resources that are available.
Okay, so basically, in theory, everything that is indexed in GoTriple can be put into this chatbot, because actually you can put it into a collection and then actually you can pass it to the notebook as I shown before. So the limit is that sometimes, even if you say that the PDF is accessible, for example, you might have some issues because the PDF is not immediately accessible. Possibly either URL is no longer valid or you have a page in the middle, etc. Also, the limitation that has just shown was done on purpose. That is just to limit costs and times, and also the time needed for processing. We decided just to limit the number of pages, for example, that the PDF is composed of to be passed. But again, this is something that might be released as a more, let's say, free-to-use service once we have the possibility to experiment with LLMs that we don't have to pay for.
Can I ask, sorry, just a specific question? So there was two papers I was looking at, both from the same journal, but just published in different years, and one is on Go Triple and one's not. And it's the more recent one that's not. Is there a reason that has changed?
Okay, yeah, this is also another thing that, if I understood well the question, so basically what we have decided to do is just to limit this functionality for documents inside GoTriple. So for example, technically speaking, I can add my own document, for example. You know, I have another thing that perfectly matches, for example, my notebook. And this is again something that might be possibly added as a, let's say, premium functionality.
Okay.
So, but we are still discussing about it. I guess that, of course, technically speaking, there isn't any reason for not doing this. But of course, there is cost to consider. So,
thank you.
Thanks a lot. Any question, anyone? Okay, so thanks a lot. Oh, sorry, Thomas. I haven't seen you.
Thank you, and I hope you don't mind me prodding further. The question from Crystal, which I would be interested in, is what's kind of the information cutoff of Go Triple? If you're talking about a chatbot, it's always kind of until when does it have information? If I publish a paper today, when is it going to be in Triple?
Okay, so actually this is not strictly related to the AI, right? Okay, so basically it very much depends about the frequency by which we do updates from the sources. So for let's say that normally sources are harvested once a week. To be perfectly transparent, right now we are in the middle of a migration to PCSS. So right now basically we blocked updates because just we actually want to start again with a brand new and possibly more powerful architecture. But normally, if the document is published in a source after, let's say, 1 week, more or less, is there. Also, it very much depends what is happening at the same time. So if base, for example, is publishing 1 million documents as an update, of course, this, just made everything, go slow. Okay, any other question? Go Triple, chatbot.
Let's thank Luca again. Thank you, Luca. And I'm glad to call on stage Jan Pomi by ESTF, who is going to demo the GraphDB to your graph functionality. So you already seen yesterday the GraphDB for the tennis example of the knowledge graph. And you'll discover today more about the functionality that they built into this application for allowing people to chat with the content of the knowledge graph.
So thank you, Matteo, for the opportunity to let me present a proof of concept that we did at ESDF with GraphDB stored to your graph. So I would like to present you the context. Back in May, we had an event called Cultive Ta Data in Montpellier, France, during which we presented the activities and the skills of the companies to potential clients. And we wanted to showcase one of the tools of our of our partners, which is GraphWise. In a concrete example, so Jan and his assistant Margot always spend a lot of time to do financial reporting for a European project, because you need to retrieve multiple data, such as the percentage spent on the project, the base salaries of the people invested in the project. These data are located in different files across different data sources. In our case, it's Notion and Dropbox, and so we told ourselves that AI could help us with this issue. So the typical way you would do it is via a retrieval augmented generation, which basically allows a LLM to answer your question based on your data, on your files. Basically, you will have the ingestion of the data, in which you will pass to your pipeline the files, chunk it into little pieces, and then transform them with an embedding model to allow it being stored by a vector database. And that will allow you later on, when you will run queries against these files, it will allow you to do similarity search, so you can retrieve the pieces of your files that are relevant to answer your questions. These chunk of files are then passed to the prompt of the LLM, and then the LLM, with the updated prompt, is able to answer your question. However, in our use case, we have to how could I say that? We have to query multiple files. We have to query timesheets. We have to query payslips, etc. And this is something that a similarity search engine struggles to do, because it cannot detect the relations between these two files. So we told ourselves that the knowledge graph could be AI, and knowledge graph could be useful for this use case, since the knowledge graph will tell us, will expose the data of our companies and the relationship between them. And so this is a great idea on paper, but you have to provide some way for the LLM to know what to actually query on your graph. And so for this, you use ontologies, which have been explained yesterday, so I won't go too much in details in there. You could also view the presentation that did Julien back in the day that has been linked earlier. And so basically this is what we did. We created fake company, completely fake companies with fake payslips, fake invoices, fake expenses, and we modelized all of this with an ontology, in which basically you would have employees being employed by a company. This company will lead projects for other companies. These companies would issue payslips to employee, and most importantly, these employees have tasks that are attributed to them, and these tasks are related to a project with a given total of person per day. So with this ontology, we have modelized everything that we need to answer our use case. And the advantage of using an ontology file allows us to explain in detail the contents of the graph, especially with the domain expert knowledge. Since when developing your ontologies, you always cooperate with the experts of a domain. It also allows us to provide the scopes and rules for the LLM. So if your graph contains too much data that you don't want, you can just pass the ontology, and here only we be aware of what the ontology describes. And something that also helps is that we can provide more context through comments, through RDFS comments, and that happened during the development of the ontology, in which this has a real impact, because we made a copy-paste error in one of the comments of one of the concepts, and because of that, the LLM wasn't able to answer the question, and just because of a comment. And so this ontology, how will the LLM use this ontology? So we took the talk to your graph tool developed by GraphDB, which is an agent that is able to query the knowledge graph in several ways, whether it's with similarity search, full text search, with connections to external databases, like through the ChatGPT retrieval connector, which basically works like a traditional graph I presented earlier. But it also supports SPARQL queries to answer the question. Each approach have their own advantages. The SPARQL query is good in one case because we need to explore relationship between our earlier concept and to do some math on the data, because LLM can have trouble with simple math. So how this works is that when you send a prompt to your talk to your graph agent, it will just like a classical RAG, take your prompt and pass it to your LLM. However, it will add two things. First, the ontology you provided, like really the dump of the ontology, and it will also pass it all of the functions, so the different ways to query our graph. And so there will be a first call to the LLM to tell him, so you have this question, you have this ontology, and you have these ways of answering the questions. Which tool should I use, and what arguments should I pass to it? And so the LLM thinks, returns what the tools to use and how to call them. In our case, it returns. It says that we should use the SPARQL querying, and it has generated with the ontology we passed to it in the context. It generated a SPARQL query using his knowledge of what he knows about SPARQL during his training. And so then with this generated SPARQL query, the agent will just run it against the triple store, retrieve the result, send the results to the model, so it can finally give a final answer based on the retrieved data. So this had consistent results. This allowed as well a lot of flexibility on how do you query the graph, because you could tick all of the options at once or just one. However, we had some issues because it needs a lot of tinkering, such as the model temperatures or the randomness of the responses, and also some additional instructions such as read the whole ontology, try a different approach if you fail, etc. So it's quite tedious to deploy, but it works quite well. Sorry. So as of the event cultivata data, so we tried three ways. So with a classical retrieval augmented generation, so it was of course able to find the documents within the graph. However, it had a lot of semantic issues, like the classical RAG couldn't understand that in our context, a person is the same as an employee, because there is no semantic layer. And of course, it couldn't use the links between the documents. So then we used LightRag with generated KG. LightRag is a solution that is able as well to generate some kind of knowledge graph between big codes. So it reads the whole files, try to extract all the entities it can find, and try to create relation between them. However, it was pretty decent actually to find facts that have a common point, such as looking into resumes and expenses export to get expenses export from engineers of a company. However, since the knowledge graph has been, since this knowledge graph, so to speak, have been created by AI, the indexing wasn't correct sometimes, so it would have detected a project, but it would never have linked it to anything. So all the person days, all the tasks, etc., wouldn't be linked to it. So it would lose some of the added value. And we also tried the talk-to graph with only the similarity search built in GraphDB. However, it gave good results. However, since it could not explore the relationships, it had to make many function calls. So it had to call the model loads of time, and it even timed out. So the reasoning was correct, but we could never have the results. And so then we tried, and then we used the talk-to graph with the SPARQL query, and I will show you how it yielded. So sorry, it's in French. I don't know why I couldn't make it work in English. So I've asked the graph to sort by descending order all employees that made the most task grouped by project. So as you can see, the model was able to understand the task, to generate an appropriated SPARQL query that targets tasks, employees, and person days. And so we have these results. So if you're curious, and I do think that this approach could be useful for some of the LLMs in Graphia, especially since in task 2.1 we have to provide an ontology. So maybe this approach could be used to explore the graph. If you want to try the GraphDB talk-to graph, you have a GraphWise provides a sandbox in which you can spin up a temporary instance of GraphDB with a connection to OpenAI. Thank you.
Thank you, Jan. Now, I'm very glad to share a demo. As you can see, given the nature of the IPL, we are not showing things that function perfectly. It's really work in progress. The demo I'm going to show now, it's work we started 2 months ago, close to Quagga and the other things. So it's very work in progress. But just imagine, so this demo works with the Open Citations meta knowledge graph. So allows you to query the Open Citations knowledge graph. Imagine that in the future, it will be able to use it with other knowledge graphs. So It's a command line interface, and I ask you another exercise of imagination. Also imagine that in the future, there might be a more complex GUI developed in the project that integrates this functionality. It's really to show kind of the bare bone of what this can do. It starts with the SPARQL endpoint of Open Citation, and already with the checks file, so the shape of data that we discussed before, already pre-generated for the interaction with the user. In the future, it might do this on the fly. So if the SPARQL endpoint that the user wants to explore, it's not pre-indexed, it will do it on the fly, maybe a couple of minutes, we go for the configuration that is fastest, and then the user can start exploring that. So I know I'm asking you lots of imagining things, but that's a bit where we are right now. So let's say I'm gonna start with how many journals exist in the knowledge graph. So just gonna ask my question. You have different colors to show the interaction between the agent and other tools that the agent is calling, and I'm gonna explain them in a slide just at the end. So the agent provides you the answer, so there are 80 million, roughly, journal articles, and gives you also, in the spirit of things that we can check, is not just giving you the answer, but it's giving you the query that you can run in order to get the results. So we know, how many articles there are in there. We can try to be a bit more, precise, like with a more sophisticated query, but also a bit colloquial, in the sense that we are saying how many journal articles are in OCM, how the model does actually know that OCM is the acronym we're using for the knowledge graph. It doesn't matter. We're asking for articles published in 2024. So here, there is some red appearing because one of the functionalities of the agent is kind of auto self-debugging the query. So it comes up with a query. The query is based on information that is retrieved from the vector database about the shape of data, but if that doesn't work, it's gonna retry. So that's one mechanism, and the other mechanism is trying to refine the query, aligning the vocabulary to the vocabulary of the ontology. So what we discussed before about synonyms and different words being used for the same things. So it's aligning, trying to realign the stuff, trying to trying to come up with a SPARQL query that actually produces the results. Hopefully, also this one is not going to break, but at the same time, it's producing a log where in the log, well, at some point will also maybe be shown to the user, and the log, it's interesting. You can see, for example, the different queries that have been tried and didn't work, and you can also see the parts of the knowledge graph that are pulled by the agent. So this one seemed to take a lot of time. I mean, with 4 billion triples in there, that's also kind of understandable. Let me try another one on trying to retrieve the title and the publication date for a specific journal article, of which we know the GUI. So again, the same process of trying to come up with a query, validating it, running it. Here in green, you can see the reformulation that the agent is using of trying to realign the thing and actually come up with finally a query that works and gives you the answer of the title of the paper with that GUI and when it was published. In this case, the model, the agent was having trouble to understand how in the data model of the knowledge graph, the GUI is expressed. So it starts with an hypothesis and then looks in the examples, not examples, but looks in the shape of data of the knowledge graph to come up with the most precise SPARQL query that, that compiles. So maybe just a last one to, hopefully that will run faster, using some not full text search, but like text search on the titles of the article, like how many journal articles have archaeology in the title. There should be about 13,000 when I checked last night or this morning. So again, the same process of trying to come up with the right SPARQL query, and the performance and the running time. It just doesn't depend on the model. It depends also on the back end of the knowledge graph of the disease querying. So it's kind of a complex pipeline. Sometimes we also ask for queries that contain aggregation. So counting things, aggregating them, and providing an answer. All of these queries and some more were kind of working before. So some of them are not working now. I'm gonna leave this running a second and see whether, I go back to it and see whether we get an answer. But just to kind of unpack a bit what's going on here in the agent, which I think it's, you know, independently from the fact that it works now, like for all the queries or not, but kind of the architecture is the following. So we have, the idea is translating the question into the SPARQL query. The agent that we are using is that Qwen3 coder, so it's at 30 billion parameters to kind of orchestrate the agent. We have the tool calling, which is the important part. We have different tools that are doing different things in the agent. So the agent can call them, for example, to validate the query, to retrieve the checks, so the shape of the data, to retrieve a sample. So the prototype we have right now is not using like all of them, but that's planned for the future. And then it's also this functionality that you have seen in action of reformulating the query to get it to finally work. So all these tools can be called by the agent based on the query. And then you have the vector database that contains in the following kind of a RAG system, as Jan has just showed. It contains pre-extracted information about the boy, the checks, and the sample. It all goes into the vector database, and then depending on the query of the user, the agent is pulling the chunks of these different bits of information that are most relevant in order to provide the context that then allows the agent hopefully to come up with a SPARQL query. Let's go check. And we have the result back. So there are 13,116 journal articles with archaeology in the title. So yeah, are there any questions? I try to do it as Speedy Gonzalez as possible.
Just one super quick question. The use of the word archaeology as a search term is interesting. Depending on which part of the English-speaking world you're in, it might be spelled differently. Yes. Is there a way? Yeah.
Yeah, but that's also interesting. It's a question of synonyms and the different wording. So the linguistic knowledge that these models have is huge. So they are all these. We were discussing yesterday, what was it? Like, I don't know, different labels in different languages. The multilingual knowledge I have, it's amazing. So we can count, I think we should tap on that and exploit that in order not to have to figure out all these small details and let the model and the agent do that for us. But yeah, that's a very good point.
Yeah, I was curious about like where would that happen? You know, like in the checks or in the query? No. It would be in the LLM.
Yeah, this is the knowledge, the linguistic knowledge, the factual knowledge that the LLM has. Yes.
Thanks, Matteo. A question about the DOI prompt that you gave it. If for any reason, say, an article didn't have the DOI information, but it had everything else about it, would it still be able to find it, or is it just? Do you see what I mean?
Yeah, if you're asking for an article with a DOI, if it doesn't have it.
But I mean, like it exists, but it just isn't in the open citations for any reason. It's just.
Yeah.
No, just.
It will not find it, but
yeah, sorry. Even if the article itself is there, if all you have for the information of the article is the DOI.
If it's not indexed in open citations, the agent will not find it, because this question is answered based on the content of the open citations knowledge graph.
The only reason I ask is I believe Graphia might tap into the GoTriple database, and in there it varies whether things like DOIs are included in the metadata on articles, and I just wondered if there's any way to standardize it so that DOIs are like reliably available, because that is something that maybe people will search by. Does that make sense?
Yeah, it does make sense, but even despite kind of the availability of the DOI, the question you are kind of hinting to, I think, is the issue you're hinting to is the coverage of these databases, like the coverage of open citations, the coverage of Crossref, the coverage of Matilda. When it comes to the humanities, they're not covering 100%. So there might be things that don't have a DOI, things that have a DOI that are not indexed for some reason. So there will be a question to convey to the user of the question you're asking, I cannot answer to it because it falls beyond the scope of this knowledge graph, or all plenty of huge edge cases that we'll have to deal with when it comes to kind of interaction with the user. And I think doing some kind of, not now, but when there will be an interface, kind of proper testing, maybe with some of the users that you already contacted, will be super useful, because that gives you an idea of like what is a natural interaction of a user and what kind of cases you have to anticipate that this agent will not be able to respond to.
Thank you.
Yes. Maybe we keep it to like one last question, I guess.
Can you scroll up to where there was the red line when there was the error and it didn't find the thing?
Yeah.
Can you show it?
Yeah.
So who wrote the error running in query? Like, where did that text, who wrote that text?
The agent.
Okay, because basically having the phrases like "you did something
Yes.
wrong," yeah, it was a bit like
Yeah.
And then I didn't realize that it was going to then try to attempt it. So it'd been better maybe
Yes.
to say, "Let me clean up that text or the code for you" or something.
Absolutely.
Yeah. So it was just it was a minor point, but it really kind of was like, "You did something wrong."
It is actually, but I had the same reaction when I saw it. Yeah. And it's a discussion we've been having of like, now that the bare bone, not the bare bone, but like the architecture is there, you need to polish, all this interaction to make it natural for the user as well. Yeah. So that they're all important. Okay. It's important feedback. Thank you.
You have the influence to change the way that is. It wasn't like
I don't. Harsh, who is the genius behind this, he does.
Right. Okay.
Thank you. I think we probably have to stop here. I'll be around. I'm leaving later this evening. So I thank all who contributed to the workshop with the demos, Jan and Luca, and all of you for the interaction. Thank you.
Thank you, Matteo. And just to let you know, there's been between about 30, 40 people online following you. So actually, it's been a lot of people online.